we've got a few missing today. Don't know where Abhishek is. There we go, we'll start, eh? Guys, as I said yesterday, we have to go through some basics first. As we go through the basics, then we move on to the more, events, electronic controls and whatnot. But before we go on to the electronic stuff, let's have a look at some principles, particularly looking at the fuel injection system prior to electronics, working into electronics, and then we'll go into common rail, okay? So we'll start with a great picture of two of our Cert 3 students. Look pretty smart, don't they? Where's his shirt? Alright. I keep using my mouse, but I can't. Where are we? Okay. We all know how to service a filter, I hope. Brian, you know how to service a diesel filter in a diesel engine?
Oh, the different?
Have you done one, I should say? Maybe it might be better. You've done a petrol one. Have you done a diesel filter?
Oh, not yet.
Not yet, no. All right. Well, have you, yes?
I've got one filter in my car, brand new one.
Yes.
And I've got, it's underneath the car.
Yeah. Oh,
if
yeah.
you want to look at it.
They're a pain to do, aren't they? Yeah, I've done them before.
Yeah.
Yeah. Well,
no, this one is mounted on the chassis rail.
Yeah, I still think that pain to bleed, I think, from memory. I've done them before.
Yeah.
I might be wrong, but I know what you mean. We can do that, but...
No, this one doesn't need a bleed.
We should do. It will do.
There's a Toyota Hilux and with Nissan Navaris. They have this thing on top of your pump.
Yeah, they do. Yeah.
Some, the electronic.
Yeah, some electronic.
So you turn on the ignition 10 times, on off, on off.
A lot of cars you need a computer too.
Computer. I've never used a computer, but I've learned this too.
When I say computer, use a scan tool.
Yeah.
But look, we can look at that, whether we do it today or next week, but we'll do it definitely, because in one of our practicals.
Yeah.
Changing the filter?
Yeah.
Okay, so I'll go on.
Yeah. I need one of my cars too.
Okay.
So we'll practice for you, Brian.
Yes.
Okay. So when you do a diesel filter, Brian, we need to clean the area where we're doing things. Why do we want to do that? Any ideas? Why we
because
want to
of the fuel contamination, any dust, if a tiny dust goes in the power plant can clog your injectors and...
So, people that are specialists in doing fuel systems for diesels, they actually have to have a dust-proof area. They usually have a room with an exhaust fan to cause a vacuum so no dust will be in there. And they're very particular because it's so critical, particularly with the common rail diesel where you've got high pressure. High pressure, any sort of little bit of dust or dirt will be abrasive in that system, so they have to be. So we need to also be careful when we're doing those things. If we undo a pipe, it's good practice to cap the pipe we undo, okay, with a plastic cover or something. That way you limit the risk of dirt getting in there, all right? So when we do that, we also have on the bottom usually, and not always, but a little drain thing that we can drain the fluid out. But that's there for two purposes. It's also there for any sediment that's on the bottom to drain that out as well. So sometimes if any water is in the system, it's going to sink to the bottom and the diesel will float on the top. And often it will pool in the bottom of the filter or the sediment pole. Okay.
Just a quick one.
Yes.
I found a very good technique. I always keep a pack of that little balloons.
Balloons?
Small balloons.
What balloons?
No, balloon.
Balloon.
Yeah, balloon. Right? And whenever you undo any diesel pipes,
put the balloon in.
Put the balloon on.
And if it starts leaking, you fill up the balloon.
No, but it works. The little ones.
Look, if you had nothing better, that's better than not doing anything, definitely. No, great. So just to be conscious of being clean and making sure we put new seals in when we replace them and that we bleed the system afterwards, okay? Any air in the system affects the running of the diesel. It can actually stop the car from starting, so we don't want that. All right, moving on. I just talked about sediments settling on the bottom. Some of them have a little sediment telltale on the bottom of the filter to tell the light on the dash to come on if there's an excessive slush, that might be the word, or sediment in the bottom of the filter. So that's a warning for the driver. Got to change my filter or clean out the sediment. Okay. You can check that sediment float by a AURETR, of course, and I assume that as the sediment settles, it's heavy enough to push the float down, which will then obviously turn the light on, whereas diesel's a lot lighter, the fuel. Okay, pretty basic really. Again, different types of components. There's an element type of fuel filter. We don't see that so much, although they're coming back again. My Hilux's pretty sure is an element. It is an element type, so they're coming back. But in the old days, we used to have a long shaft going through with a bolt on the end. And you used to unscrew that and get diesel all over you as you pull them off and all that. But nowadays, I think mine and my Hilux are just a little plastic canister that you pull off, and then you can unscrew the plastic bowl, where that would be a metal bowl most likely. But similar setup, yeah.
Most likely it's a cartridge.
Cartridge.
Yeah.
I call it an element. Cartridge, same thing. Yeah.
I've also seen the glass ones.
Yeah, the glass ones are there to catch the. Oh, so you can see if there's water in the bin.
Yeah.
Mostly in the trucks I've seen.
Yeah, they do.
The truck and tractors used to have the old tractors.
Yeah. So if you've got, if you're servicing the vehicle and you look at the sediment bowl, which is glass, which often they are, and there's water in it, it'll always be on the bottom, so you can tell. Again, some of the banjo type bolt fittings for filters, right? So you've got the eyelet that goes in, like the pipe's got an eyelet, and then you've got what we call a banjo nut that screws on, which is what we see there, that nut with a hole in it. So the fluid goes through, when I say fluid, the diesel goes through that hole, then there's a little strainer there. That's a trap if you don't look at that, in case it's getting clogged up, it could restrict the flow. So just something to think about. I probably haven't seen that in the later cars, but certainly in the older type, and maybe trucks might have it. So
Toyota 2C had one of those.
2C, that's an old diesel, isn't it?
Yeah, old diesel Toyota.
Back in the 80s, I think, yeah.
Yep, they had.
Yeah. So yeah, all right. Bleeding and checking the fuel system. Any air that enters the system must be removed. Otherwise, that air gets trapped into the diesel pump, gets pushed into the injectors, and the car won't run on air. It needs to run on fuel. So we need to bleed it off before we start the engine. And I'll say before because I told you, you won't hear Mohammed yesterday, but I said diesel is a lubricant. And if we don't have diesel running through that injector pump and through our injectors, okay, we have no lubrication of the moving parts in those parts. And that causes premature damage to the either the pump and maybe the injectors. So if we prolong the winding of the diesel now, particularly the common rail diesels, it's not good. It's not good. We actually cause some damage. So just to be aware of that. So we want to bleed that. There will not be enough fuel pressure to start the engine if there's air in it either. Air will enter the system when the filter or other parts have been replaced. To follow, the following is a method of using a manually bleeding system. So, we can look. In the old days, we used to loosen off the injectors. Okay, and we used to wind the engine over and all the fluid would come through and we'd see all the air go through. We don't do that now because the high pressure system that goes to the injection now, they reckon it could pierce your skin and get in your bloodstream and you could be dead in no time. So we have to be careful, okay? Just to be careful around the high pressure. But yeah, I won't read through that, but we're going to demonstrate that downstairs. Most of the stuff I'm talking to you today is a little, someone here?
Hello?
Hello?
How you going?
Good. I'm sorry.
It's Nick from London.
All right. So yeah, we'll do the bleeding at the practical side and changing the filter, so we won't worry about going anymore. Again, like a petrol engine, we've got fuel pressure, both in the low pressure and in the high pressure. Some diesels, right, and the earlier diesels, the high pressure wasn't that high, but we still call it high pressure. The pressure that went to the injectors, right, had to be high enough, to work the injectors. But the low pressure, it's probably lower, like the same pressure as a petrol engine, the pressure in the low pressure system, but in the high pressure it goes up. If we're talking about common rail, there's a big difference in pressure, okay? There's a much higher pressure. But we can still check pressures on the low pressure side. We can still check flow, okay? So in that picture there's a little container being catched to get the flow level of how much diesel's going through, so we know there's enough diesel flow. Remember when we did petrol engines, we talked about we can have good pressure but bad flow. It's the same with the diesel. So we must make sure we've got a good flow. Often I would hook up a plastic clear pipe in the low pressure side, particularly on common rails. I'd even make it long enough to go up to my windscreen so I could drive the car and make sure I wasn't getting air bubbles coming through. Because if I have a drivability problem, often it can start with the low pressure side, and often it can be bits of air coming in, particularly if we get a bit of a misfire or hesitation at times, okay? The other thing that can happen, fuel can drain back into the tank and we get this massive log of air and the car wants to wind over before it starts. Again, having a plastic, and you do that with petrol cars too, a clear plastic pipe, you can buy it from Bunnings, just hook it up to the fuel and make sure it's only on the low pressure side and just check that there's no bubbles and that the fuel doesn't drain back overnight and cause a hard starting issue, okay? All right.
Hi, in this video I'm going to show you how to prime the fuel pumps in your 2009 Plus TI engines. On earlier models you could just turn the key to on and that would run the fuel pumps. The 2009 Plus models, that won't work, so you have to manually prime the pumps. There's an easy way and a hard way. The easy way is to plug in your VCDS cable, look for the green LED, and use the software to prime the fuel pumps. After you plug in the cable and start the software, turn the car on, go to Control Module, then Engine. Now there are two ways you can run the fuel pumps. The first one is through output tests. Use a drop-down menu and then go to Fuel Pump Relay Control Circuit and then start. It'll cycle the fuel pump on and off, as you can see here, and I can actually hear the fuel pump in the back running. Now this only runs the fuel pump in the fuel tank, so I'm going to prime both pumps by going to Basic Settings, Group 35, and here you can see the test parameters, prerequisites, ignition on, engine off, test duration 30 seconds. Now if the fuel lines were completely dry, I would want to do this for 60 seconds as specified in the service manual at least 3 times. But if you just open the fuel lines, change the fuel filter, or a few drops came out during timing belt replacement, 30 seconds 3 times should be okay. Go to on off next to start the test. And here I can actually hear both fuel pumps running. The one in the main fuel tank and the one by the engine, the auxiliary fuel pump. Let this run for 30 seconds, repeat 3 times, and the fuel pumps will have primed the fuel lines. Then click off to stop the test. Repeat as desired. Check for leaks, start the engine and go for a test drive, and then check for leaks again. If everything is okay, you've successfully primed the fuel lines. Thanks for watching the video. Now if you don't have VCDS, you have to do it the hard way. You have to manually jump the fuel pumps to run them. First you have to remove these little trim pieces that cover the child seat anchors. They're curved, so you just pull them out around the metal guide. Then pull the rear bench seat out. First you have to pull up on these clips here that are holding the bench seat in, and then it comes right out. Lift up the carpeting and pop this little cap off. I've already removed this for demonstration purposes, but here you can see the power and ground wires that run the fuel pump. These other 3 wires are for the fuel level sensor. Use your own multimeter to verify the wiring. Then jump the positive and negative with something like a battery charger. This will run the main fuel pump in the fuel tank. And then you have to prime the fuel pump by the engine, the auxiliary pump. To the left side of the engine is this pump here. There's a rubber boot covering the contact, but if you pull it off, you'll see the negative sign there, and then the positive sign. Now, as you can see, getting access to all these pumps and then running them back and forth is quite a hassle, so I recommend using VCDS. Again, run the fuel pumps for 60 seconds, 3 times each, and that should prime the fuel pump. Thank you for watching the video.
So that's an example of a diesel having two pumps, one in the tank and a lift pump near the engine. If you don't have the ability to run those pumps using your scan tool, what a job that is, you know, to pull seats out to get to the second pump. So it's important to have our modern diagnostic equipment to be able to do that. VCDS, if you're doing a lot of Volkswagens, VAG type vehicles, you need to get a VDCS. I have one. It's a compatible software you put on your laptop with a dongle that you use and plug in. I think, I'm going back too long now, but I think when I bought mine, it was only like $600 to buy the dongle and the software, but it's probably a lot more now. But honestly, it's the closest thing you get to a factory scan tool, that particular scan tool. Only good for Volkswagens and Audis and Skodas and the VAG group and whatnot, Audis. But look, I just thought I'd run that video. We don't have to, in a lot of cars now, we don't have to actually bleed the fuel by having it open and catching it in the can like we used to. That will just cycle back to the tank and bleed the air. And that's probably the same with your Land Rover, Alvin, that you would bleed it through back to the tank. So bleeding, when I say bleeding, doesn't necessarily mean a bleed a nipple or pulling a hose off to bleed it. It could mean that, yeah, you run it through the pumps and pump it back in, okay? But if you don't do that, you won't start the car. You get a gut full of air. All right, moving on. Okay, checking injector spray. Diesels. We're going to check diesel injector sprays if we don't have a injector tester.
Spray, sir.
All right, back in the early days, when
We had that pump
yeah,
sort of
well,
thing.
we had those two. In the earlier days, look, we could pull the injectors out, the diesel injectors out, with the lower, still high pressure, but lower high pressure. We could actually run the car and look at the injector spray, or wind the car over and look at the injector spray for a short time. We probably wouldn't run it, we just wind it over. And we could see, after we run it, we could let the keys settle for a minute and make sure there's no drips coming out. If there's no drips, it's good. If there's a nice spray, it's good. We could do that, bit of messing around, you know, and people did that. But, you know, having the proper bench tester and everything's probably better. With our modern diesels, and we're going to learn as we move on, we can do feedback checks, we can do things to get an idea of the injector without pulling them out, which is a much better way of doing it.
Can you scan tool to individually
Yes.
shut down injectors on each cylinder
No.
and see the difference?
No, not to my knowledge, although I could be wrong. The piezo injector, right, if you turn it off, it'll either be on open or closed, okay? If you turn it off when it's open, it's going to stay open, okay? It needs to turn off before, so you don't disconnect, never disconnect a piezo injector and check if it's misfiring, never do that. Only because, yes, you could wreck the motor by having a gut full of fuel go in and bend a conduit.
I mean, using a scan tool, I've seen there's a provision where you can go and individually.
I can't remember on a diesel, I'm not saying definitely, but if it was a piezo injector, and probably a high percentage of the modern cars now use piezo injectors, right? So I'd say probably unlikely on the modern cars. Maybe on a solenoid injector, that's a bit different, maybe. But if you get into the habit of not disconnecting, or if the scan tool allows you to do it, that's fine. But I wouldn't disconnect injectors anymore, just so you don't run into the risk of maybe having a piezo injector open. Okay. So as you said, there are test equipment. There's the best way of checking diesel injectors, right, on a test bench. Yes, there's some more portable ones that you can pump, you were talking about. They're okay for a small workshop if you're not doing a lot. But yeah, I think, you know, if you're doing enough diesel, some of this equipment, you probably wouldn't go as far as getting a bench test like that, but something like that is viable. Okay. I didn't have one myself, but I know shops that did, and yeah, I had the petrol one, but not the diesel one. All right, and also we need a really high pressure gauge on particularly common rail diesels. But you know, on the common rail diesels, we can get scan data that tells us the pressure okay, because you have a pressure sensor on the common rail. The only problem is, on the odd occasion, you can have a faulty sensor, okay, and you think you got good pressure when you haven't. So that can be a trap. So sometimes, and I know people who got caught there, okay, so sometimes it is necessary to be intrusive and check the pressure on a common rail diesel. We talked about doing feedbacks. Has anyone seen this setup before? Mm-hmm. No? I actually want Nina to get me a set of that so we can show you how it works, but I'll show you a video of how it works in a minute. I won't go through all that because you're going to see it in a video, okay? I've got 2 videos about it. We'll look at the first one.
The purpose of the fuel injectors is to deliver the correct amount of fuel into the combustion chamber at the right time. The diesel return flow kit is a great tool used to aid in fast and accurate diagnosis of these injectors. G'day, I'm Zach and welcome to Automate. The common rail diesel injector houses a solenoid and a two-way or control valve. The engine control module, or ECM, supplies the current to the solenoid, activating the control valve. This opens the outlet orifice, allowing the fuel in the control chamber to drain or leak back. This reduces the pressure in the control chamber, forcing the command piston to lift and opening the injector nozzle. Fuel is then able to enter the combustion chamber. To shut off the fuel injector, the ECM deactivates the solenoid, closing the two-way valve. The nozzle is then forced down by the rise in fuel pressure above the command piston, thus ending the injection event. If you'd like to know more about injector operation, please watch our videos on common rail diesel. Diesel return flow kits are a great way to test and diagnose CRD injection systems. By measuring the return flow of diesel from the injectors, you are able to easily compare the return value against all other injectors and OEM specifications.
This is a sample of the hundreds of training videos we have available, covering everything from technical fundamentals, diagnostic procedures, equipment and wiring diagrams. Automate is simply the best training available. So why not join us today? Start training and be the best technician you can be.
Okay, Brian, how does that work? How do we use a feedback system to make it work? To check the diesel. Yeah, you weren't watching, I know you weren't. You were looking at your phone, that's why I'm asking you the question. I want you to learn, I want you to understand. So if you're watching your phone, you're not going to learn, are you? Okay? Alright, you've got a second chance, Brian, because the next video is going to show you.
Hey guys, Brendan from TAP. Today I just want to show you how to do an injector return leak test on this ZD30 Common Rail Patrol. Quite a common test that you'll do on Common Rail diesels is the injector return leak test. So in this case we've got a ZD30 Patrol Common Rail that they've got a complaint of a long crank intermittently. So I'll show you what I've got hooked up and you know, the things that I go through before I get to doing the injector bottle test, and we'll look at the results. So one of the first things you're going to want to do with a common rail complaint like this, of long crank, is hook up some clear hose. So I've got that going from the fuel filter to the fuel pump itself. Idea being, if we had some kind of leak in the vacuum feed system up to the pump, as the car sits, that's going to give it a chance to have the fuel revert back to the tank, and you're going to have to suck that up. So we want to leave it sit and make sure this stays full of diesel, and then also while it's running, you know, you can easily do the test of seeing that there's no air bubbles in there. So we're happy with that. Another common thing that can cause a long crank on these that we've already done the video on is the relief valve down in the rail that lives underneath of there. But a first and easier test to get to on these that is definitely well worth it for a long crank, particularly on these Bosch systems like this run, so that includes your Ranger and many other cars, is a bottle test. So we've got some bottles here, many different kits. So we've just got 4 hoses going from these individual containers down to, I'll grab you a light quickly, down to each of the injectors, and we've just taken the return hose off. So I'm going to get you set up. So this is our rail, if you like, that controls the return flow from the injectors. So I've got that disconnected from each injector. It's just a little clip, pop them out, and then I block off the fittings there just so we're not sucking air in through it. Then we just fit a fitting onto the top of each injector. If I grab the kit to show you. So this is the specific kit that I'm using. It's just got a bunch of different adapters in there that go into different injectors. A Blue Point kit, if anyone's wondering, but there's many other ones out there. So I'm going to start this car now, and we're going to watch the rate that those bottles fill up. So not too bad a crank there, but you know, I'd say slightly, if we're splitting hairs long, but intermittent, he says, so it does get quite bad. And we can see we've got one injector much worse than the others, so follow that down, and it's managed to fill the hose and fill its bottle, whereas you can see, say for instance, this one over here, the others have barely made it, you know, a quarter way up their tube. So we have an extreme return leak from that injector. Now that's going to be bleeding off a bunch of fuel while it's trying to build rail pressure, so I'm confident that's going to be our problem for a long crank. It tends to get worse when they get hot because the viscosity of the diesel changes and it leaks even worse. So this will need an injector, 200,000 Ks on it, so I'm going to recommend he does a whole set on it. So that's a common basic test that you'll do on a lot of common rail diesels, particularly if you get a long crank complaint like this, and particularly if it's a Bosch system being a common failure mode of them. Aside from this extreme example, which it took 15 seconds or so and it was already overflowing one, generally you'll see not more than much of a trickle coming out of each injector, and we're looking for balance, right? So after a minute or so of running, the bottles will just be starting to creep up a bit. It takes a while to fill the actual lines, just starting to creep up, and we want to get to about half, three-quarter bottle or so, so we've got a good sample size there, and you shouldn't see much difference between them. So anything from, treat it just like a compression test really, I like generic type things. There will be specs for specific vehicles, and if you can get them, great, but as we know it can be hard, so treat it like a compression test. We don't want to see much more than say 10-15% variance between them, or else that can give you reason to say, look, depending on your symptoms you may want to take these out and put them on a bench test, or depending how far the variance is. So hopefully that helps you out, guys. For more tricks, tips, that kind of thing, get on to www.tat.net.au. We've got a video section there with all kinds of tests like this, right through to programming using J2534. So check it out, and we'll see you next time. Thank you.
Cool. But actually, most likely going to Brendan's shop in about 3 or 4 weeks' time, just for an excursion, and he'll show us some of his great diagnostic stuff that he's got.
Yeah, do it when I'm back from Fiji.
Sorry?
Do it when I'm back from Fiji, and I can go as well.
He probably will be back, because he was talking, he's got somewhere away at the moment, so he's quite busy, but he's talking about the first week in July, possibly. You'll be back?
Yeah, I'll be back before that.
I haven't responded yet to that date with him. I just wanted to check that we're still doing.
So he basically did a return leak test.
Yeah. So what a return leak test is, okay, we're looking at when the fuel goes into the injectors, okay, it goes under a certain pressure, and when the pinnacle is open, or the spindle is open I should say, fuel will go into the motor, and then it shuts. But that fuel keeps circulating, then it'll bypass the injector, then it'll go back to the tank. So we're feeding the fuel that's going back to the tank in those bottles, okay, the return from the injector, right? If we've got a gummed up injector or a pintle that's not working, okay, it's going to be more fuel going back, okay? The opposite, if we've got too much fuel going in, we're not going to get so much feedback, right? So what we're looking at those bottles, we're looking to see a reasonable level each cylinder, each injector. So if there's 4 injectors, we want to see within 15%, I think, is what Brendan said, and I agree with him, and there's all little scales on them with numbers, so we can scale them on the bottles, and we want to see that they're all fairly even. A little bit here and there outside the problem, but a lot out, like that one was way out. Okay, so that injector's not even working. So we want to see. And what happens when that injector is not working, it's probably bleeding back all the pressure from the rail back into the actual fuel tank, and that's why it's hard starting. Okay. So
So that means the injector isn't opening and spraying into the vehicle, so it's blocked, it's going back to the
I
tank
think
straight
so.
away.
Yes, yeah. So anyhow, there is a definite problem there. Some cars are nearly impossible to do the feedback, right? Because of accessibility. But a lot of the new cars now, we look at that compensation value, that feedback value on our scan tools, so we can still get an idea there. Brandon, I remember him once playing with the pressure transducer for a PICO pressure transducer. He put that on the return line because you couldn't get to all the different individual injectors easy. And he could see each one of them because the pulse would change as it would come and go. And he was able to work out, yeah, there is a problem or they're all even. So that was a pretty smart thing too. He might talk to us about that if we're lucky when we go and see him. He might even show us. But anyhow, I thought I'd show you that. I used to use one of those feedback tools regularly. They're very inexpensive, under $100. I think I've seen them as cheap as $25 online. You don't need anything. You make one up yourself, but for the price you pay for them, it's not worth it.
Are we doing this leak down test, this injector test?
If I can get Nina to buy us a kit, yes.
Yeah.
I'll see it. I'll ask her. I'd like to.
Before I continue, I've got a story. So one guy came in with a Assessor D-Max,
Yes.
but he didn't tell us that he put petrol in the diesel vehicle.
That'd be right.
All right.
Yes.
And the vehicle was misfiring badly,
Yes.
knocking.
Yes.
We tested the fuel.
Yes.
Then recommended him to change all the injectors.
Yes.
And then we also changed the fuel pump, fuel filters. Then it was working perfectly. But the customer didn't tell us that he put petrol. We had to find out.
You want to hear a story?
Yeah.
I was asked to give a second opinion. This customer had sent his diesel car to a workshop, and they were trying to fix this problem. And they pulled his motor out. They stripped his motor down and said he needed a new engine. Anyhow, he didn't believe them because it wasn't a high mileage car. So he packed all his engine in the back of his ute or trailer or whatever, brought it to me for me to have a look at it. Within about half an hour or less, I worked out that he had petrol in the car. You could smell the petrol. And so they pulled the motor apart for nothing.
Sure.
Yeah, so that was a devastating thing to happen. Yeah. Anyway, so the other thing we can do, this is the it's called here the fuel correction quantity. See that? Remember we talked about those numbers yesterday? You look at the scan tool and see the injector. We've got injector 1, 2, 3 and 4, so it's a 4-cylinder. We're looking at those values, and remember I said no more than 2 difference, positive or negative 2, more likely 1.5 is more my goal. 1.5 positive or 1.5 negative. I think it was on the screen the other day. If you look here, you reckon they're within that range? Look at those numbers. See anything out of the ordinary? So we've got minus 0.3, then we've got plus 0.4, minus 1, plus 1.1. There's not more than...
0.5, it's not more than 0.5, it should be good.
Yeah, so there's not a problem there, is there? So pardon?
There is one, it should be 0.5, there is minus 1.
No, 1.5.
Oh, 1.5.
Or
Minus 1.
Minus 2.
minus or plus 1.5.
It should be in between.
Within that range, which they all are. So I don't see a problem with that. But if I saw this was 2.1 and this was minus
1.7.
2.1, you know, that'd be a red flag then, okay? All right? And just on the borderline, it's still a red flag, all right? All right, this guy, I like this video. He's interpreting the information on the scan tool. This is the sort of stuff that you guys really need to understand, and not only understand, but different types of cars or manufacturers might have a different sort of value to a Toyota for an Audi, for example, you know. So you need to learn a lot of this stuff, and experience is the best way of learning, but also learning from others who've got experience. So we'll listen to this guy, eh?
Hey guys, just another quick diagnostic video, and I know I've done a lot of different diagnostic videos. The reason we have though is because there's a few differences between Prados, Hiluxes, manuals and autos and stuff like that. So this is another 2007 120 Prado with a 5-speed auto with 172,000 k's on the clock. It had original injectors in it. I'm not sure if we did a video on this one with the readings, but I can tell you that the load was up around 20 or so, so about double or even higher than what it should be. Now, quite a number of times I've said what the load should be, and there's probably about, I would estimate, 1 in 10 vehicles where the numbers don't quite come down to what most of them do. So don't be concerned if you've got new injectors and you've done all the job right and everything. You've got our injectors, our pipes, our gaskets, our procedures, one of our recommended repairers, or yourself after your training in the VIP group. If something like this happens, don't be concerned, okay? This is basically two weeks in a row, so I'm not sure if I released the other video, but I did put a video out, and this one's going to sort of say similar things. This one, for example, the intake was a lot cleaner. I think maybe someone's cleaned it before. It's got a catch can on it, maybe that had something to do with it as well. Wasn't good, but it wasn't too bad, right? But the main reading we're looking at here is, sorry, I got the sun shining a bit here, but hopefully you can see what's going on. We're at full operating temperature. You can see the coolant temp. Excuse me, I should have taken a drink first. I've got some water here, luckily. See the coolant temp, it's sitting on 86 at idle. That's probably just needs to cool down a little bit. I just got back from a final road test after replacing the injectors. Yeah, I was meant to drink that water while I was on the road test, not when I got back, and I thought, you know what, I'll show you this. It's mainly that calculate load reading, right? I've said it before, a brand new perfect set of injectors would be 11. So if all the injectors are new and you've got a reading like 12 or 13 or 14, we've seen it. As I said, we saw it last week. It's not something to be concerned about. It just means there is something there that's creating a bit more load. And it could be as simple as the alternator's been replaced with a different alternator that's got a different duty ratio, like depending what percentage this alternator's on, we may get to that. But there's a few variables there. 9 out of 10 you're going to get these low readings, and you may drive the vehicle and it may even just settle in a bit and come down at a later date. Sometimes I've seen these, as I mentioned in other videos, up around the 13, 14, and they just stay like that for years. So it's not necessarily a big deal if it's up a little bit. Normally it's in the range of 11 to 16. Above 16 would be replace injectors. So mental note with this one, if it's on 13 already, we're going to add sort of about 2 or 3% to that. And it's not just about the load reading. Let's have a look at the other readings and see, by having that slight extra engine load, what other readings change as well. So let's go down and have a look. Sorry about the reflection, like I said. We'll go down to all the other usual readings we look at. See the injection volume? It's up around 7, where that could be around about 6, you know, and seeing even higher, around 7.5, 8's not completely. Now this isn't a 150 Prado. 150 Prado, they do sit a bit higher, around 8 or 9, and that's what I'm trying to say. It's not a big deal, because the 150, the only extra load on the engine, what's the difference there? What are we talking about? Not much really, okay? And that's where the fuel and the load is on the 150s. It does sit higher, so we're somewhere in between a 120 and a 150. But I'm just trying to point that out. Now, feedback for these 1, 2, 3, 4, all good. Pilot 1 and 2, always around the 430 mark, very good. We're happy with that. Pretty steady around there. Main injection period, like I'll normally say, they're normally around the 550 to 600. Around 600 is good, but this isn't a problem. It's just a little, the main injection period, little bit higher than, a little bit longer than they normally are, but not bad. But by me doing a number of these videos and you watching all the diagnostic videos, and I think we've got a playlist called Diagnostics, Injector Diagnostics, or Injector Information, and I'll add this video into that playlist. You need to get into those playlists and watch all those videos on whatever particular topic you're interested in. Anyway, right, moving down, let's go and have a bit of a look further down. Timing all looks pretty good, so take a look at that. 20, 14 and 3 roughly on a 120 Prado. Right, we'll go a bit further. Let's look at the fuel pressure for the people that don't want to watch videos and watch the other videos. So even though you started calling me names using swear words, I'm still going to help you. So look, you know, I'm sorry if I wasn't helpful enough for you, but remember, I don't owe you anything. I spent a lot of time putting free information out there, and I know a lot of people are going, you know, stuff those people, and you're dead set right, but you know what, let's just we'll forgive them. And this is a really good example on how one to check fuel pressure on. This is actually awesome, guys, and anybody that's been watching my videos knows what I'm about to say, and that is, you can see the target common rail pressure on 35 because it's at full operating temp, right? Steady. And that's not always the case either, but usually it is. And normal good fuel pressure is anything from 32,000 kPa up to 35,000 kPa. So 32 to 35 is your most common sort of readings. Now you can see every now and then it's jumping up to 36 and dropping to 31 really quickly. And if you keep watching, you might see it go under 30. You might not too. So this is not really bad, but this will be one of those cases where it's got the short suction control valve in it. It's not the end of the world. If you've got symptoms like stalling and stuff like that, that is a symptom of you need to replace the suction control valve on any of these diesel vehicles, particularly with these compact type suction control valves. They're rubbish, as I said in another video. This video is about diagnostics, not suction control valves. Anyway, fuel pressure is not too bad, but when it's good, the normal is it's really steady between 32, 33 kPa up to about 35. And this isn't bad, but you can see every now and then, see it's pretty good now, pretty good. And it just did that jump up to 36 and right down to up and down a little bit, right? And if you watched it long enough, you'd certainly see it go under. And we can go on another screen and look at a graph that shows you the highs and lows and whatever, save the highs and lows and all that sort of thing. See, just went up to 37,000, so it's a bit all over the joint. So it is worn, it is tired, it is a short one, it is rubbish. Once it gets replaced and gets that long one in there, it's going to be much happier. Okay, so there's a bit of checking fuel pressure. Maybe I'll put in the description how to check fuel pressure in this one. The other thing you can do is, we'll just quickly say, hold it on 3,000 revs. Get it steady and see what it does. It should do about the same. See, it's on about, the target's changing because I can't keep my foot still enough, but it's around about the 64.8, the target, and the actual's jumping around a little bit, up and down a little bit. It's not bad, right? So that's another part of the testing or checking fuel pressure. And the other one is, you give it a bit of a rev up, and how fast does it go up and down, chasing that. The fuel pressure's got to chase the target very closely. And how closely? Well, that's what you get to learn by testing a lot of fuel pressure on a lot of diesel vehicles. You'll get to know what the normal is, and then when you see heaps and heaps of those and you get to learn what normal is, then when you do it and you've got one that's not normal, you go, that's not right. And it can be very subtle differences, so it takes experience. So it's hard to teach checking fuel pressure to someone that's never done it before, but that's kind of like what you're looking at. But it's going to be hard for you to tell. They can be very difficult to diagnose, all right? But you probably haven't got a problem with fuel pressure on a 1kd because the pumps and everything's really good. Now, see over here, it's still idling on about 85, 86. So this thermostat's causing the vehicle to idle a bit warmer. It doesn't mean it runs warmer, okay? It just means it's idling a little bit warmer than what they normally do. You can see the load still around the 13, a bit like the one we did last week. Anyway, guys, that's what I said. It does happen every now and then. Most of them, you know, readings can sit lower. Let's have a look at that injection volume again. As you can see, around 7, it's up about 1 mil, sort of a bit like the one last week, up a little bit. You got a little bit of load, so it adds a little bit more fuel. Feedback values are good. All the other injections are good. I'm happy with that anyway. It's a non-issue. Just trying to point out that everything isn't always kind of perfect, if you know what I mean. Alright guys, thanks for watching. If you got something out of that, please remember to give us a thumbs up, subscribe, please turn the bell on so you don't miss that next important bit of information. Catch ya.
So I like that guy. I've never heard or know him or seen him before. I just happened to find him and I thought, yeah, he knows what he's talking about, okay? But my whole idea of that was to give you guys a little bit of insight, because you see all these values on your scan tool, but if you don't know what you're looking at, you know, you've got no hope, have you? So you don't know what's good or bad. The TAP website, to give them credit, they do have some known good scan data that you can always go to as a reference. But again, it's limited because it's only giving you shots of before you start the car, while the ignition's on, while it's idling, and at 2000 RPM. So I give you all those three ranges, which is helpful. But, you know, it's better that you learn and you hear from people that have got experience and probably start to work. Don't just have a scan tool to find out fault codes. Anyone can do that. Find out how to interpret the live data. That's what I want you to learn and consider, okay? So that takes time, takes effort, it takes education, okay? Oh, is this still recording? Because I had a phone call before and sometimes that cuts it out. It is good. All right, let's talk about injector coding and pilot learning, okay? What I'm talking about, have I got some injectors outside? I think I do. Can I? So here's an injector from the diesel. I'm just trying to find the code on it. Can't see it. It's going to have a code though. I'm blind. Maybe my light.
You might have a look.
That's weird. Have a look. It's a bit dirty, by the way. Got to be a code on it, surely.
Yeah.
Ah, there it is.
Then so.
Oh yeah, now I can see it. So it's a bit hard to see in this bad light, but there's a code there that you'll have a look in a minute. Oh yeah, that's better, yeah. So that first number up the top there is what you code into the computer when you change an injector. Each injector has a certain amount of, values of how the injector has been when it's been manufactured. They will test it and the computer will know by that code and it will actually then compensate for whether it needs to be adjusted just slightly, okay? It's important to put that code in. It's important not to mix up your injectors from one place to another. If you mix them up, you will upset the coding, okay? So if you do mix them up, you'll have to go and code them all, okay? But that code would be hard to see when it's in the car, wouldn't it? Yeah. From there. This is out, I'm pretty sure, could be wrong, but I think it's out of a Hilux. It doesn't look like a Hilux one, but I don't know why I think it is. But nevertheless, see that threaded hole there? Yeah. That's the return. The bigger thread,
feed. That's
the feed in. So the diesel comes in through here. It will then either go through the nozzle. There's the end there where the injection happens. There's a very fine discharge jet there. It'll spray out of there. There's an oil seal there to seal it. There's usually a seat. See where that seat is down the bottom there, just along there, like that, where the hex is? There'll be a seal there, a washer.
Copper washer.
Yeah, that washer is critical. You must replace that washer every time you pull one of these out. You must clean that seat, both on the injector and in the actual cylinder head. It's critical to have a good seal there. What can happen over time, if that seal starts to leak, which it can do, you end up leaking combustion into the engine crankcase, okay? And it creates a lot of sludge in the oil. It's not good, okay? And yeah, it's a problem that some of these users have where they leak. You actually lose compression from it, okay? So it's important that it seals well. But that is a common rail injector, and you can have a look at the markings on it and see the numbers. What I used to do, I used to take photos of that number, right, on each injector, and when I put them in, then I'd use my camera then, I'd go 1, 2, 3 and 4, so each picture was in order of cylinders, and then I'd go and do my coding, and then I wouldn't make a mistake.
The latest one have got that QR scan code on it.
Have they?
Yeah.
That makes more sense, doesn't it?
Yeah, I've seen, like, I've just put one in the workshop,
Yep. Yep.
and they had a small scan code,
Yeah.
like QR scan,
Yep.
and my scan tool has got a scan camera on it,
Right, right.
so you just go like scan all those codes and it just fits.
That's the easy way.
Yeah.
Because, my way, sometimes you think an O was a 0 or an O,
Yeah.
put the wrong thing in, so that way you never make a mistake. Fortunately, if you do make a mistake, generally it will reject it because it knows that you've typed something in wrong, but better not to type anything in wrong. All right.
Is that what it hit to?
So Common Rail,
Injector.
pilot learning. Pilot learning is before, as the compression's coming up, before the main injection happens, there's short squirts of diesel going in, ready to heat up and help burn the combustion. And that pilot injection has to be also adapted, okay? Yes?
QR,
Oh, there is a QR
Yeah.
code.
but it's been very light here, but there's a QR on top.
Boy, I can see it now.
Yeah, there's a QR scan.
Okay. I'm pretty sure that's out of my older Hilux. I put a new set of injectors in my.
Let me see if I can see on the camera.
I put a set of injectors in my Hilux, not because I had to, but it done 200,000 Ks, and I just felt it was a good idea to put new injectors in. So, all right. So the pilot learning is something that we also set. Okay, we have to set with our scan tool in a lot of cars. All right. There is a certain adaptive learning, like fuel trims are. The car will learn as you drive it and adapt the pilot injection. But it's probably better if it's meant to be set on a scan tool to do that whenever you change an injector as well. Okay. So this is a G scan. And this is the putting the code in for a certain injector, right? So you just manually put that in for each cylinder, and that's what it looks like.
There you go, Maura. There's a code and everything on top.
You got it?
Yeah, there's a QR scan and the codes on top, on the plastic. That's really hard to see, but like it's been...
Yeah.
Oh wow.
Yeah.
Oh, one over V.
Yeah.
Because we are.
Yeah?
Is that a we are cop?
Yeah, yeah.
We are
So
coffee.
Thank you.
ये QR code scan करेगा, scan tool से automatic.
All right. So, pilot injection. In order to reduce engine noise and exhaust smokes in common rail diesels, a small amount of fuel is injected through one or more small micro injections, also called pilot injection. Okay, so that's what I was saying earlier. And these micro injections occur just prior to the injection pulse. The actual number of micro injections will vary from vehicle, between vehicles and ECU programs, or particular vehicles. The number of pilot injections will also depend on the running conditions of the engine, example, temperature, speed and load. Micro injection learning may be performed automatically whilst driving under certain conditions by the ECU, monitoring changes in RPM immediately after pilot injection has occurred. The ECU can be increased or decreased. The ECU can then increase or decrease the micro injection quality to achieve the optimal quantity required. Okay, so pretty much it can be self-learned. But I do know a lot of, like Notice for example, they like us to put do a relearn through the scan tool before we, after we change the injectors. So it just depends on the manufacturer, I guess. And if we're doing a pilot injection relearn, and if we're using, for example, the G-scan, which this is a G-scan 2, you go through actuation testing, and you go up here and it'll be prepare ignition. Can't read, it's all blue, but anyway, you go up to what it tells you to do and goes through the different steps, okay? And this is following that, special functions, performing Quantity learning is another name for pilot learning, I'm pretty sure. Special functions, you go into small injection learning, execute, and it does it for you, okay? Alright, who's ever removed an injector that won't come out of a cylinder head? We all have, haven't we?
We actually had to replace the engine because we couldn't take the injector.
And did you have special pulling tools?
Everything. It was so jammed in.
Yeah.
It was a Senion Action.
All right.
So 3 injectors came out.
Yeah.
The last one wasn't coming out.
Yeah.
And we did all sorts of things we couldn't. We had the tool as well.
Yeah.
Screw it on and knock it out.
You know why that is? You know what reason why it does that? Why?
I don't know.
You don't know? Because
water underneath.
Because of that seal leaking,
Yep.
and it leaks the exhaust gases.
Yeah.
You get all the carbon built up from the hydrocarbons and that from the exhaust gases, and it just clogs up the injector so it can't come out. I had a Ford Ranger, I think it was a Ford Ranger diesel. 2 injectors came out, but 2 were a nightmare.
Common problem with PJs.
We ended up getting it out. I'm pretty sure, it's a while ago now, but I'm pretty sure we sprayed lots of CRC in there. We got a lever and we gradually twisted it like that until we could loosen enough, until finally we could get it out, okay? Probably a good idea, if it was a piezo injector, I would then replace the injector. If it was a solenoid injector, you might be okay. But if you, it's very easy to damage a piezo injector, okay? And they can get stuck in there.
And then with the Ford Ranger, the PJ Fords,
yes,
has got a common problem.
I think that was what I had trouble with.
Yeah, the PJ ones, and all those injectors.
Yeah.
We've got like 3 or 4 utes.
Yes.
And like every time we have to do like injector, they get stuck there.
Yeah. And that's why they went in there. All right. So I guess removing the injectors to when you undo the pipes, do you just undo the pipe with the injector, or do you undo both pipes?
Both.
Yeah, good
Both.
answer. Because you distort those pipes. If it's a common rail diesel, you're meant to replace those pipes every time you undo them.
Okay.
People sometimes don't, and they don't leak, but sometimes they do. Sometimes those pipes are inside the rocket cover, and if they leak, you fill your sump up with diesel, you can ruin your motor, so you can get caught. So you're probably wise to replace those pipes. Okay. Why do we need to replace those pipes? Every time you do them up, okay, they get distorted a little bit, okay, they seal the first time, but after a couple of times they get distorted, okay, because they sort of are on a flange, like, I'm going to put this one, yeah, I'm not sure, but sometimes they're on like a tapered flange, and they will actually, they will cause distortion, and when you're at high pressure, which a common rail is, any sort of weakness, it will start to leak. I've had I can't remember what car it was now, but whatever it was, I had a pipe once leak after I changed the injector without changing the pipe, but it was an external leak, and it made me realise how bad it is. Also my Hilux, when I went up to Northern Territory, I noticed I had a lot of oil under my motor. I'm thinking, well, that's not good. And we did change the rocket cover gasket and that before we went. We actually had some new injectors fitted, and after that we had an oil leak. We changed the rocket cover gasket a second time. When I got up to Darwin, I found out it was leaking, but it was a very wet leak. I thought, oh, my injectors are leaking. So when I got to Broome, I ordered a new set of pipes. I fitted a new set of pipes in Broome, and that slowed the leak down because there was diesel leaking from those pipes, but it didn't stop the oil leak. I still had an oil leak. It wasn't until I got back to Brisbane, I found out a hairline crack. They use a plastic rocket cover. There was a hairline crack on the
rocket cover.
So I had to replace that, but yeah, interesting. So I had probably a long period of time with oil leaks in my Hilux because of, and all we did was change the injectors thinking we're doing something for pre-maintenance reasons, and we introduced a second problem. My staff fitted it and must have cracked the thing on the cover. I didn't know, but yeah. All right. So I think make sure we tension down the injectors when we fit them if to the right tension. Make sure we tension down these to the right tension as well. There's a certain tension for those.
Is there any special tool to clean that injector hose?
I saw a video when I was looking for videos this time round of one of these places that have a clean room for injection work and that. And before the car goes into the injection room, they use sort of a special vacuum cleaner thing to suck up all the dirt and dust around it. I thought that was interesting. Generally what I would do is use a rag, I'd spray some Carby Clean, use a rag around it and blow all the dust and dirt away and wipe it with the rag before I undo them. That seems to work for me. Yeah. Everyone's got their own little thing, but you just have to be conscious that we don't have loose dirt that can get caught. I've had injectors where I've laid them down like this on the bench, and when I put them back in, and I don't know whether piezo or normal solenoid ones, but when I've done that, I've had problems with the injectors. I found if I sand them up and then I put them back in, I don't have the same problem. Things go wrong when they lay down sometimes. And I think that's because there could be already some sediment and stuff inside the injectors, and by laying them down you've disturbed that, you've moved it around, and then when you put it back up and put it back in, it gets caught and you get an ejector problem. But if I keep them very steady up and down, I don't seem to have that problem. So. True. All right. Talking about that washer, right? The seal, that we need to be looking at. And this is about installing it, talking about keeping the seat clean where the injector goes, which you just spoke about.
There's a special tool as I was thinking about.
There is a little, sort of looks like a thing to ring the...
Like a die or the cap.
That's right.
Rimmer sort of thing, yeah.
Exactly. Yeah. All right. I guess I want to talk about timing, okay? The timing, particularly, not so much with our common rail diesel pumps, because I don't think the timing is critical, but certainly on our earlier model injector pumps that we had, the old school ones. Even though we've got a mark here on the timing belt, and we keep that all lined up, and we lined all that up before we take the belt off, that's not a problem. But what happens if the belt broke and this, we lined that up with there, everything right, put the belt on, do you think we're going to be home and hose and everything will be okay? Possibly not. Why? Because behind this injector gear here, some of them have other gears in behind the timing case, okay? So they have the timing belt on the outside, and this whole cover behind that is covered up with other gears where the injector pump is geared to that pump there, and we could be out on those gears internally, right? And I've had that happen. I had that on the Ford Ranger. I had the staff put a new cylinder in. That one that the injectors got stuck on, they were changing the head over on that one and put it all back together, and it wasn't running very well. And because they got the timing wrong.
Is it the one at the back? Back of the motor, behind the motor? Behind
the timing case. Behind the timing cover. So behind... So that wasn't... That's not... In some cars, some cases yes, but in some cases it's not actually joined directly to the injector pump. It's geared from there to the injector pump. Okay, so what can happen is it can be out, and you might have to turn the motor dozens of times before you can get it timed properly. Okay, so you can get caught. So my advice is, if you ever do a timing belt, don't rotate the motor without, and get everything lined up, and then don't touch it, and then you'll be okay. All right. Nothing's been disturbed. All right. Things that problems with engines. Okay, we have a low power, and it's not just this only, but some of the things for low power can be timing out an injector pump. Can also be faulty injectors. We're not getting enough fuel or getting too much fuel. A blocked air cleaner. Could be a blocked exhaust, couldn't it? DPF blocked, so it could be other things too. Engine idling bay. Some of the earlier injector pumps, they used a manual, what's called a governor, okay? The governor controls the, the RPM and You know, the more reds we've got, the faster the government spins out, so the more fuel we get, okay? So it governs the amount of fuel delivery, I guess. And so that could be faulty. Injectors faulty again. Inspect the pump for wear. You know, the pump itself can be faulty for bad idling. I had, I forget what car it was, but anyway, it was a diesel that was idling very poorly. And it was a real problem. And I think it was more of a problem when it was cold or hot, I can't remember, but heat did play a part in it. And remember that video we talked about, the guy said that the fuel thins out more, or the diesel thins out more when it gets hot. So I guess when it was hot, maybe it played up more, I can't remember. But whatever the problem was, it ended up being an injector pump. So the pump itself was worn. White smoke. What causes white smoke in a diesel? You're probably reading it. White smoke in a diesel. Yeah, again we say faulty injectors. We can say incorrect timing. But one of the biggest problems is compression. White smoke's caused by a lack of combustion happening, okay, with the fuel, and we get white smoke coming out. And if we have low compression, we get less heat in the actual combustion chamber. Less heat results in less of the combustion being properly combusted. So yeah, it can be combustion related, and I've had that before. You know what else I found that causes white smoke? When people put petrol in and mix it with their diesel fuel. That causes white smoke too. I've had that happen, okay? Alright. Keep getting all these messages.
And also when your coolant mixed with...
Yeah, coolant can cause white smoke too. Yeah, a few things can, that's right. Okay, overheating, okay? Did you believe injectors can cause overheating?
Yes.
In a diesel?
Yes.
How can that be?
If the injectors are on
leak injectors.
Yeah, leaking injectors, because when we put more fuel in, okay, when we overfuel a diesel, what happens to the combustion temperature?
It rises.
It rises. What happens on a petrol engine when we put more fuel in?
Lowers.
Yes.
Opposite.
It's the opposite, isn't it? Yeah, we learned, you weren't here yesterday, but yeah, we talked about that. So yeah, the more fuel we put in, we don't use the word rich fuel, we use overfueling in diesel. The more we overfuel a diesel, the cooler the combustion is, and vice versa. The lack of fuel, I said the wrong way around, my apologies. You know what I'm saying? The more fuel we put in, the hotter the combustion, definitely. Hotter the combustion in a diesel. The less fuel we put in, the cooler combustion for a diesel, opposite for petrol. That's important to know. Does everyone know?
Yeah.
So I'm just going to ask Brian, if I put less fuel in my diesel engine than needed, is that going to lower or increase my combustion temperature?
Increase.
Increase. Did I say less fuel? Can I have another answer?
Yeah, you said less fuel.
Less fuel is going to lower my combustion, okay? Lower. If it was a petrol car, yes, but a diesel, it's going to lower, okay? More fuel is going to what?
More fuel can lower and...
No,
Low fuel goes higher.
it's increasing. The more fuel we put in a diesel, the higher the combustion temperature.
So more fuel will increase higher?
Yes. But remember, it's the opposite for petrol. A petrol engine, a gasoline engine.
More fuel is decrease.
Yes, and less fuel will heat up more. So it's the opposite. A lot of people don't know that. That's why, yeah, it's important to know, okay? All right, so we could have faulty injectors. Yes, we can have injector timing out. And naturally, we can have a cooling system problem. But I guess the point of this is, if you're dealing with a diesel that's overheating, don't rule out, that it could be overfueling, okay? Don't rule that out. Engine knocks. Again, I've heard engine knocks in diesels that sound like a big end's gone. You swear the bottom end's gone in the engine, but it's only because it's getting too much fuel. Okay, it's knocking, or it's been timing too early and it's knocking. Can have air in the system as well, and injector timing's out. Black smoke. What's causing black smoke?
Extra Unburned diesel.
Yep, so it's overfueling, so we're going to have injectors that are dribbling, air cleaner blocked, injector pump timing late. Okay? Misfires, faulty injectors, leaking injector pipe to unit, so we're not getting full pressure at the injectors. Air in the system, faulty injector pump. There could be other reasons as well, but they're some of the common ones. And engine starts, but will not run. That was like Brendan Sorensen's video. His car was hard starting, wasn't it?
Yeah, very intermittent.
Yeah. So in this case, we have an air system problem where we could have carbon up intake ports going into the cylinder, so we're not getting enough air in it. That could be a problem. We could have a faulty pump supplying fuel. We could have a blocked filter and fuel low in the fuel tank. So even low fuel, we can get air sucked up or sediment sucked up or anything, but yeah. So there's a few things, okay? I didn't go through what to check, but I think that's all self-explanatory. Exhaust smoke. We talked about black and white smoke, but you know, one of the things with diesels is often look at the exhaust pipe. Not quite as easy as it used to be, meaning that we've got now diesel particulate filters in there. But once, before we had DPFs, we could look at the exhaust pipe, but we can do to a degree still, okay? We'll still get white smoke sometimes and black smoke. But you know, look at the colour of the smoke, which is indicating what, unburnt fuel. White smoke, as we talked about, could be incomplete combustion, which could be low compression or other things. And blue smoke, we can talk about blue smoke. What's blue smoke? Oil.
Burning oil.
Burning oil, yes.
So what color of the smoke that it mean the car is good? No color?
No colour, yeah, pretty much.
No
yeah.
smoke.
Yeah.
No smoke.
No smoke?
No smoke.
If you ever studied some of Clinton's talks, he'll tell you that he breathes the exhaust out of the tailpipe to get a feel, and that's how he diagnoses cars sometimes. You can tell if the car's overfueling, underfueling,
Or it's
burning oil.
coolant leak.
Yeah,
Coolant can smell like
That's
different.
right. Yeah. All right.
In other words, they used to have a $1 bill check for the combustion, for the compression thing.
Yeah, do that in petrol cars.
Yeah.
Okay, we just. What's the time?
10:30.
Right, what we'll do, I'll come back and we'll talk about those questions and we'll go into the second half after we've had a break, okay? Thank you.